Certainly the CAD people know how to make beautiful drawings that are understandable by humans. So there's sort of human factors side of this that, there's various websites about ugly maps and so on. I know the cartographers out there do a great job of trying to make things beautiful, but they can gain inspiration from their CAD cousins who know how to make beautiful, beautiful drawings that are very, very useful for humans to look at and make good decisions quickly.
Hello and welcome to another episode of the Mapscaping Podcast. My name is Daniel and this is a podcast for the Geospatial community. My guest on the show today is Dale Lutz, and he is the co-founder of a company called Safe Software. They're the ones behind the feature manipulation engine FME. Dale's been on the show before. First time he was on the show, we were talking about the evolution of geospatial file formats. Now, this might not sound that interesting, but Dale is an incredibly entertaining speaker. He's a wonderful guest, and I would highly recommend that you go back through the podcast feed, find that episode, and listen to it. I'm sure you'll get a lot of value out of it. In this episode with Dale, we're going to be talking about GIS and CAD, and we're going to be doing a little bit of comparing and contrasting these two systems. So the hope here is that we can demystify some of the issues we run into sometimes as geospatial professionals when we're translating between these two worlds. Just a few quick messages from me before we get into the episode today. I can see that a lot of people are listening to the podcast on the website. So if you're a podcast fan like me, you will know that listening to a podcast in a podcast app, when you subscribe to a podcast through an app, through a podcatcher as they're called, the experience is significantly better than listening from a website. So if you haven't subscribed, I would recommend that you do so. That it'll be a much better, cleaner experience for you. I also just want to take the time now to really thank the fans of the podcast out there that are sharing the podcast with other people that might enjoy it. This is how this podcast is going to grow. This is how we're going to grow the community. And this is how we're going to spread the word about geospatial. And I really appreciate those people that are taking the time to recommend the podcast to a friend. Thank you very much. Okay, that's it from me. Let's get into the interview with Dale. Hi Dale, welcome back to the podcast. Thanks for taking the time to do this. I know that you guys have been really busy with your FME World Tour, but you've taken the time to talk to me again, and I really appreciate that. The first time you were on the podcast, that was back in episode 43, and we were talking about the evolution of geospatial file formats, and that might sound boring, but you did an amazing job of making it interesting and sort of really talking us through what it looked like back then, what it looks like today, and where we might be going. So anyone listening to this, if you haven't listened to episode 43 already, I would encourage you to go back and do so. And today we're going to be talking about GIS and CAD. And just before we dive into that, perhaps you could take the time just to give the listeners a brief introduction to yourself and your background.
Thanks, Daniel, for having me back again. My name is Dale Lutz. I have worked with spatial data basically more or less since I graduated from university way back in '88. And in 1993, started a company called Safe Software with my friend Don Murray. Back then, there was two of us, and we started off to build translation software for an emerging format called SAIF, SAIF, which was really a grandfather in many ways of modern GML. And what's really interesting about that beginning was that one of the very first things that people wanted to move in and out of SAFE was data that was held in CAD files. And so we started by mentioning my previous podcast around the evolution of data formats. I think today we're going to be talking about those early amphibians coming out of the primordial ooze up onto the shore, and that would be the CAD files, and then being transformed into maybe the mammals that are the GIS files. The CAD people will be mad at me for that analogy, but hey, look, the crocodiles are still around, so they don't go anywhere.
I don't know what to say, Dale. When you have an opening like that, I'm just not sure where we should go from there. That was radio gold. Okay, so it's clear where your allegiance lie. They are to the GIS, to the geospatial world. But we're going to talk about both today, GIS and CAD. So I think a lot of people listening to the podcast will have a really good understanding of what GIS is. So let's jump over to the primordial ooze. Let's talk about CAD, computer-aided design. What is it? Why is it so different to GIS?
If you have to go way, way, way back and think about the early days of using computers to help represent things that are in the real world. And before there was GIS as we know it, people were drawing buildings and they were drawing facilities using computer aided design tools or CAD. And if you go super far back, there was the Intergraph Design System, IGDS, that was run on PDP-11s. And that's relevant because to actually build a translator for at least the older design files, you had to understand PDP-11 integers and floating point and crazy things like that. And so those things were very slow, and so you had to have a very optimized way of storing a drawing so that you could quickly see it on a screen and that humans could work with it. And that led to a whole set of design decisions that worked extremely well for that purpose. But then when people started to try to do more complex mapping using this kind of technology, they were very successful, but it caused a lot of interesting and hard trade-offs, which I'm hoping we get to explore. I may break into that song "Nobody Knows the Trouble I've Seen," um, because these old ancient systems were never imagined to be storing complex attribution and the kinds of things we now take for granted in the GIS world. And so that's over on the Microstation. Microstation was a PC clone of Intergraph Design System, which really used the same file format as the PDP-11, but allowed it to run on a PC. Independently, we had our AutoCAD friends come out of a different kind of angle, and they became extremely popular as well. Where we're located in British Columbia, the early mapping was actually largely done in Microstation, but other places, especially utility companies, a lot of the early mapping was done using AutoCAD. They were using AutoCAD to design facilities, and they said, hey, wait a minute, we can also start to map where our assets are out there. We'll just keep using the tools we know. So you have very skilled people, very good at collecting data, very great tools for collecting data. But now we want to start to attach meaning to things, and that's where the game gets interesting.
So let's talk about that. Why is it difficult to attach meaning to CAD data? What is it about the data structure that makes that something that's not that easy?
Fundamentally, the CAD systems were designed, as my one colleague said, they were designed to produce drawings for humans to read. So they were designed with the idea, I'm going to design a floor plan and I'm going to give it to the guys that are going to build this. And those people will be able to understand what is implied by what I have here, and they'll know what to do. That is a different thing than a computer understanding that and knowing what's going on. So those CAD drawings did not have ways of embedding what we would call attributes in the GIS side or properties. It was clunky. And the early ones really had almost no way at all. And so if you go back, my little song about the trouble I've seen, those early Microstation files, people would realize, well, wait a minute, this is a 2D file, but inside Microstation, there's a provision for a bounding Z value or Z value, a Z low and a Z high. That's not being used in my 2D drawing file. So I know I'll put information in there. I'll put a database key. I'll put property like parcel identifier number in the Z low and the Z high. These are the kind of crazy things that people did to shoehorn information in where it was never meant to belong. And so then we were fortunate enough to have these early problems and had to design a tool flexible enough for anyone to come along and start being able to pick those pieces out. Over on the AutoCAD side, people would put really crazy things inside of blocks. So the symbols had ways of tucking information in there. There were block attributes you could put in. And so then, all right, let's start putting information in those things. Or we'll put a label down and we'll put the label inside of the area. And so that will mean that that area is a certain kind of forest just because it says spruce tree on it. And a human can see that, but for a computer to figure that out, the computer has to, first of all, connect the boundary lines into a polygon and then do a point and polygon test to fish out the labels. And so these are the kinds of mismatches between a GIS approach where you actually have information, rich information attached to each piece of geometry versus the CAD where it's usually just implied or worse, encoded.
So in the GIS world, we talk about geometries. Like you mentioned before, we talk about points, lines, and polygons, for example. We attach attributes, information to them, and then we can do different things with them. My understanding is that the CAD world is that these are sort of bound together in objects. So we can have all these different geometries in one object plus other things. Is that a correct way of understanding it?
Certainly, it is for the complex symbols, which are really aggregations of all kinds of pieces. Quite often inside of these CAD systems, the symbols can be very complex collections of multiple kinds of geometry. But more common in CAD files, you really just have loose lines that you mean you hardly even have polygons as a native concept. You really just have lines, and the implication of where they are is what gives you the meaning. And so you can have sometimes more implied structures like a leader line. So the label can't fit where it's supposed to go because it'll be on top of things. So you put the label off to the side, and then you have a little line that goes from the label to where it really belongs. And so that's also one of the common sort of gymnastics that's done when you're going CAD to GIS is you literally slide the label along that leader line to figure out where it really should be, and then derive the implied relationship from that. So in general, the CAD geometry is in some respects more simple than the GIS and yet more complex. But it's simple in that it doesn't have much relationship with anything else around it other than just where it physically is. But it's more complex because you can have things like splines and arcs and other kinds of things which GIS didn't really used to have, cones, kind of complicated 3D things. So it's a really a mixed bag.
I think, again, a lot of the people listening to this podcast will understand that this sort of crossover between GIS and CAD. We understand they're two different systems. They don't always play nicely together, but they're really important sources of information for each other. So, why are they so different, but yet they're so important to each other? Why can't we easily translate between them?
It's kind of the fundamental starting point of each is different. And so if you think of GIS, you have a more structured, it's really a data management kind of situation. You're going to have schemas defined, you'll have very clear specifications, and it's very hard for anyone to go rogue and start abusing that. Whereas in the CAD world, it's much more of a wild west. And so you can give suggestions on how it should be used, but the CAD technician can sit down and they can draw anything they darn well want, and nothing about that system is going to stop them. I'm reminded of the two philosophies. I'm going to go a little rogue on you here and talk about uh, Canada versus the US. The United States founding three words are life, liberty, and the pursuit of happiness. So they're kind of the CAD people that you're not going to tell them what they can and can't do. Canadians are law, order, and good government. That's kind of a GIS sort of approach where you're really constrained. You know, the law and order are going to reign, and you're going to have to do what you want. We have gotten into situations where there's mass CAD to GIS migrations. And when that's going on, a very key part of those is a data quality step. So even if there were CAD specifications, they may not have been followed. And so it's a very common thing to run a transformation where you just read the CAD file, check against a spreadsheet of what's known to be allowed, what colors should have been used, what line styles, what level or layer names, and anything that doesn't match that, you punt it back and you say to the CAD technicians, please clean this up. This is stuff that doesn't adhere to anything in the spec. We've also done things where the naming of the levels or the layers in the CAD file was just however anybody wanted. So there you'll scan 1,000 CAD files and see things like street, streets, road, boulevards. They are all meant to be the same thing. And so you collect all the different names you encounter, you put that into a spreadsheet, and then a human goes through and groups like things. And now later on, when you do the translation, you apply that lookup and reduce the 800 variations of the layer names down to the 30 that they really were supposed to be.
So when I hear you talk about this, it sounds like it's not just a difference in data models. It also feels like it's a difference in mindset. You know, how we approach and solve problems depending on what piece of software you're using. Do you think that would be a correct assumption?
Yes, very much. Now, having said that, we have also encountered CAD deployments that have gone in with a very rigorous mindset. and basically built engines for the CAD system that enforces the rules. So, I've talked lots about wild CAD data sets. We've gone into organizations where there are the most beautifully structured CAD files you can ever imagine. And modern systems like, I think it's Maximo, that IBM has, that basically enforce a CAD standard it's for facilities management, but it requires the CAD files to behave. And so there has been a rich market of CAD add-on tools that are about enforcing specifications, and those have resulted in much more tight data models, I would say. When I was talking to my support team prior to this call, they made the reference to something they call new CAD. And it's kind of interesting. New CAD is where some of these GIS concepts start to leak in. And so there's things like Bentley has XFM, which is a mechanism for storing rich attribution with the drawing elements, or AutoCAD Map or Civil 3D, which provide more structure to how you might use things otherwise. So there has been an evolution, and that mindset of a more strict specification definitely is now much more available to organizations that want to go the CAD route.
So one of the classic problems we see when we're converting from GIS to CAD, CAD to GIS, is GIS obviously has a coordinate system. CAD doesn't seem to have at least a geographic coordinate system. Do you see that changing over time? Is that going to be a feature that we're likely to see in CAD in the future?
So that's such an interesting concept or issue. I remember vividly back in the early days of SAFE when I used to do support myself, being on a phone call with someone that was a MapInfo user for their whole life. And in MapInfo, you always had to have a coordinate system. It was very hard. You could choose non-Earth, but it was pretty darn hard to make a map in MapInfo without a coordinate system. So this person was using an early FME to go from DWG to MapInfo, and they said, "Hey, you guys, you're missing the coordinate system. When I bring it into MapInfo, there isn't one." And I start to do some probing and asking, and after several minutes, began to realize there was no coordinate system at all, as usual, in the CAD file, and it was outside of that person's imagination. I remember when they realized it, they go, "Ooh, this is going to be a problem." And oh yeah, it is a problem. Over the years, this issue of missing coordinate system has been a scourge, really. And so it relies on standards and metadata. There's always these local coordinate systems. You can have tricks to affine or rubber sheet things, shift stuff to where they are. One of the things that we adopted early was inspired by our friends at Esri, where the Esri folks would plop down a coordinate system and sometimes a world file to shift a CAD file. And so if that's sitting there, FME will pick it up. And then when we're producing CAD files, we're a good boy and girl scouts, and we write out the same thing. We put out a .prj. In very modern times, the so-called new CAD that I have spoke about before, things like AutoCAD Map, can have a coordinate system in them. And I just saw rolling by at SAFE in the last week that we're going to be properly writing the coordinate system as well as reading it if you're using things like Civil 3D and AutoCAD Map. So there is a progression there. And yes, this has been a long time challenge. It is something that, as that MapInfo user said long ago, is a real problem.
Okay, so it feels like we've got a little bit of an evolution over towards the GIS way of thinking or approach to solving problems from the CAD people. Do we see the same thing on the GIS side? Do we see people moving, or systems mindset sort of moving towards a middle ground here?
Well, it's so interesting because if you look at ArcGIS Pro, for example, you start to see many of these more sophisticated geometries being possible. You see, again, I've never been a data collection person, but I'm told that the editing tools in ArcGIS Pro start to have many of the things that CAD technicians love for data capture. So there is a bit of a meeting in the middle of sorts that's happening in the modern tools, I would say. And so and so that's starting to allow these kinds of rich data collection as well as very sophisticated production of drawing, in a way, taking that GIS data and producing a drawing in quotes for a human to consume that's beautifully labeled with leader lines and all that sort of stuff. Now, as well, if you look at the most recent utilities network work that Esri's doing for modeling transmission lines and these kind of things, that is an outrageously powerful data model that has actually some elements in it that harken back to how people used to represent that in old CAD files. Only the difference, so when you look at it, it looks like something you might have been familiar with, but underneath the data model is deep and connected, whereas in the CAD, it might have been just by implication of where things were. But nonetheless, both sides definitely have been learning from each other, I would say, over the last 15 years.
So, an application that I can see is indoor navigation and mapping. I can see that this is going to require both systems to really start to play nicely together if we're going to succeed in this and have really accurate indoor navigation. Do you think is it possible that something like indoor navigation and the need and the want for this is really sort of driving that evolution that we're seeing today?
Recently, SAFE began working a lot to produce IMDF, which is indoor mapping data format that's used by the Apple universe. And the challenge right away became, as you went to these facilities, whether they were um, shopping malls or airports, just a wide diversity in the degree of rigor in how their source data has been collected. So in some cases, you have CAD files that are of high quality, a high spec. In other cases, they are much more Wild West. But yes, the indoor mapping is another one of these waves that washes, that causes change and causes a new use case for those drawings that might have only been ever used before to help a maintenance person figure out where to go. Now we have a reason to actually try to extract more meaning out of them, and that is definitely causing some more attention to be paid. It is worth me introducing yet another three-letter acronym into our GIS CAD right now duet. Let's make it a trio and throw in BIM, building information models, because BIM is in a lot of ways the unholy marriage of GIS and CAD for the purpose of building information modeling. And so BIM is, let's take the things we had in CAD where we were drawing what was there, and let's also attach deep meaning to it and make explicit relationships. And now suddenly we have BIM. And now once we have that BIM model, we can go ahead and produce drawing files for the technicians to walk around and attach the light bulbs in the right places. Or we can make an indoor mapping network to help us figure out how to get to the emergency exit in the most efficient way from each spot. So that's really a fascinating universe when we have the trio of those three-letter acronyms working together.
Do you see any one of those becoming more important than the others going forward, or are we all going to continue to be just as important as each other?
I actually see them in a embrace of peaceful coexistence where it's kind of a symbiotic relationship. All three need each other. So the BIM system definitely will produce CAD files for use downstream on that side of things. Some set of people will still like to collect their information in CAD because they haven't really decided to migrate all the way to BIM. And in all cases, the GIS can provide some very interesting analytical side. We didn't talk about this yet, but CAD really didn't have the word analysis in it. The A in CAD isn't analysis, it's aided. Whereas GIS allows you the ability to start to ask hard questions and reason about the data. And so that's where the GIS can take the data that was collected in CAD or designed in BIM and start to do interesting analysis and say, well, wait a minute, what is our time to exit from every spot in this building? Can we draw diagrams or make labels on this thing about that? Can we make heat maps of where people are actually going? Can we compute the most efficient ways to and from various spots? That's where the GIS brings its analytical tool bag into the mix and can really add some value.
Okay, so what about if we stand on the other side of the fence now? We talked a little bit about how GIS can add value and how that was in terms of analysis anyway is quite different from CAD. If we stand over on the CAD side of the playing field and look back in GIS, what can we say to GIS? What can GIS learn from us?
Certainly the CAD people know how to make beautiful drawings that are understandable by humans. So there's sort of human factors side this that, there's various websites about ugly maps and so on. I know the cartographers out there do a great job of trying to make things beautiful, but they can gain inspiration from their CAD cousins who know how to make beautiful, beautiful drawings that are very, very useful for humans to look at and make good decisions quickly, because that's been what CAD has been used for 40 years. And so there's that whole side of it for sure. And also, and I hinted at it, the CAD people have really, really refined efficient data collection. And so the GIS side can look for inspiration to the CAD systems and say, how can we design for really fast, really efficient data collection by experts? I don't know if you've ever watched a CAD technician that's a genius. I had the ability once to watch as a building was being designed by someone using AutoCAD, and their ability to jump between command line, they were typing commands and acronyms and functions by keyboard and then clicking minimally and doing absolute magic. So there's sort of a symphony of shortcuts and minimal mouse clicking actually. I think is something that the GIS people could learn from in terms of basically efficient user interfaces for experts. There's always tension between, can I make something that anybody can sit down and be successful within the first minute? How much am I slowing down the expert by having that? And so the best of both worlds is always the goal, and certainly the CAD people have nailed it as far as really speedy, efficient data collection.
So I think we've covered a lot of really, really interesting topics so far in the conversation. I want to sort of move off now and look towards the future. So when I think about a GIS technician, for example, there's a lot of sort of rumor and talk out there in the industry at the moment that this position is going to go away or it's going to be less needed, because what we see is companies coming into the market and making it easier, sort of breaking down the barriers to entry in terms of making a map and displaying some data and doing some analysis. Now, I'm not suggesting that they're offering the same kind of specialization as what a GIS technician can do, but they are sort of eroding that market that has been the domain of the GIS technician specialist in the past. Do we see the same thing happening in the CAD universe?
In the CAD universe, I don't think that we haven't certainly seen that there's really any fewer people out there collecting data and being experts in CAD. But what they are doing is evolving and learning more about the BIM side. There's a very natural progression from CAD to BIM, or as we were talking about briefly before, the new CAD. So the CAD technicians start to use extensions to the CAD system that allow them to collect attribute information at the same time, or they have mobile collected data coming in, and then that's the starting point for the CAD, and then they enrich it by using things like XFM, or they use Civil 3D with a structured data model that they can put much more intelligence into the data they're collecting. So I think that's what's going on. That the CAD technician isn't just sitting there and saying this is a red line, and I happen to know that it's a red line because I know that it's a certain kind of a road. They're sitting there drawing that line, and they're saying this is this kind of a road. It's planned. It's going to be this sort of a surface, and that's being stored explicitly. But the other thing I really want to say, as far as evolution, that I think is fascinating to watch is I'll talk about the two big kind of CAD giants, both Autodesk and Bentley, making moves to having the CAD no longer just be a tiled file that's on your desktop, but an online data set. So Autodesk has this initiative called Project Quantum. If you do some looking on that, you can find out about it. But the idea, it's more for BIM, but I don't know, but my impression is that you'd be able to do CAD things there too. And basically, in this world, we no longer are storing in a very limited data file format that's designed for speed of display, because that's really what AutoCAD and Microstation traditionally were. How can we store things to draw them quickly? Instead of that, we're going to go online. We're going to store things using JSON, a very flexible way of having as many different properties or attributes and geometries as you want. And once we have that, now we're not, now the division between GIS and CAD and BIM all gets much, much blurrier. And so I think that this online future where we're not storing stuff on our desktops, we don't care really about how fast it draws because, hey, it's going to draw lightning fast anyway. We can throw all the power of the cloud at this. And so whether that's through the iModel 2.0 on the Bentley side or the Project Quantum or whatever it turns out to be named when it becomes commercial on the Autodesk side through the Forge APIs. That's the thing to watch. And I would encourage listeners out there to go and acquaint themselves with these two initiatives, to watch where they go, because that's as Wayne Gretzky says, that's where the puck is going, and that's where we need to be watching.
That is really interesting. If the internet would become the middleman, and especially that format that you talked about, JSON, if that would become the middleman for these three big players in the space, that would be an interesting time.
And I would not bet against it. I do think it's going to take time. We didn't go from crocodiles to birds flying around, or whatever the right evolutionary path is, in a few minutes. It's going to take a while for that evolution to happen. But I think that there's such compelling reasons for that, and both commercial and technical, that I think that it's definitely something to watch for.
Dale, in our first interview, right at the end there, I asked you about the mighty shapefile, and you gave some really interesting thoughts and insights to where you thought that was going to be. Is there the same thing in the CAD world? Is there a shapefile equivalent for CAD?
That's so interesting. I actually took a look at our usage stats before our interview to see where are people going to and from with respect to the CAD formats. And so when I talk about the CAD formats in our land of FME, that really is AutoCAD and Microstation. And ironically, there's an awful lot of translations that go CAD to CAD. And a lot of them are going AutoCAD to AutoCAD. So they're using FME to do quality assurance, or they're adjusting the specifications, or they're making explicit some kind of relationships. But when I look at all those stats, shape is actually very high as both an input and output. Kind of shockingly, Excel was very high. So people are going from CAD to Excel. Like, why? They must be fishing things out of blocks, or maybe collecting point information and making that into a spreadsheet. But they're also going Excel into CAD, which means they've collected points somehow in a spreadsheet, and they want to start that off in a CAD file. But really, the foundation of these things boils down to the mighty DWG file. There are various flavors of that. In the past, every 3 years, Autodesk changed it. We're in a little bit longer run now where it stayed the same. On the Microstation side, we had the old version 7 IGDS or DGN files. Those were the PDP-11 that I love so much. DWG, pretty much still the old faithful. I am shocked when we began in the early 90s, DXF, which is an ASCII representation of the DWG file of AutoCAD, was often used because you could write programs pretty easily to produce these ASCII things. And that was a big deal back then. I hadn't heard much of it, but just recently I came across somebody or a workflow where DXF was at the center of it. And that was kind of my shapefile moment, because I thought, wow, okay, so maybe after the apocalypse, there'll be cockroaches, shapefiles, and I'm going to have to say today, DXF files as well.
Dale, you are a fantastic guest. You are entertaining, you are knowledgeable, and you are very generous with your time, and it is much appreciated. So thank you again for coming on the show. It's been a pleasure talking to you. And before I let you go, where can the listeners go to either find out more about translations between Shape and CAD, or to reach out to you personally, or to get a hold of some more information about CAD and GIS?
So I would definitely invite folks to go over to safe.com. That's our general website, and just search on there. In particular, we're having a couple of blogs going up in the next short while on these very topics, on CAD to GIS and GIS to CAD. And we've got a webinar coming up as well. So whenever folks are listening to this, they can either tune into that webinar in their future or visit the recording in their past. So there's a lot of different resources and a lot of different things to learn about this topic area that I hope that they find valuable.
Thanks again. And I'll be sure to link all those resources in the show notes so people can find them through the podcast as well.
Thanks so much for having me. I know CAD to GIS isn't quite as exciting as vector tiles in or in a spatial database, or maybe using something cool like R, but at the end of the day, it really still is kind of the bread and butter of a lot of the work that people do out there.
Completely agree. Thanks again, Dale. Really appreciate it.
Thanks so much.
I really hope you enjoyed that interview with Dale. Each time he comes on the show, he delivers a ton of value. He's entertaining and incredibly knowledgeable about the geospatial industry. There's only one problem having a guest like Dale on the show, and that is that they deliver so much value, it's really hard to squish it into one podcast episode. So what happens is when I record with a guest like Dale, is we record a whole lot, and then I sort of cut pieces out and paste everything back together and try and create a nice sort of flowing interview for you that only touches on the most relevant topics that we cover. Otherwise, I think it would simply be overwhelming for you. I mean, these are quite long interviews, and I cut them down to somewhere between 30 to 40 minutes. So I have a whole bunch of content left, which is very relevant. I feel like it would be too much. So my plan is to start creating a weekly email. And in this email, there'll be a whole bunch of relevant information that sort of relates to the podcast. Perhaps it's things that my guest has shared with me. Perhaps it's things that I've found on the internet throughout my travels during that week. And it'll also include my sort of top takeaways from each episode. So I get it that most people didn't wake up this morning thinking, hey, I wish I got more email. So I'm going to keep this short, I'm going to keep it concise, and I'm going to keep it very, very relevant. If this is something you are interested in being involved with, if you're interested in receiving a weekly email with a lot of this other exclusive content which doesn't make it onto the podcast, as well as sort of my top takeaways from each episode, go to mapscaping.com/podcast, and I'll have a lot of information there of how you can join, how you can sign up, how you can be a part of it. And that's it for another episode of the Mapscaping podcast. My name is Daniel, and it's been a pleasure being your host again this week. I really appreciate you taking the time to tune in. As always, if you have any questions, comments, or feedback about the podcast, I would love to hear from you. You can either go to mapscaping.com/podcast, join our email list to send me that feedback, or contact me on social media. If you just search for the Mapscaping podcast, I'm sure that you'll find me. Thanks again. Appreciate it. Talk again next week. Bye.